Close enough. And let's go to that. What do we want to do here? What do I want to do? We can go, nah. Yeah, we'll go do that. No, we don't want to do that. All right, reproduce that as best as you can. Lauren, looks like, and possibly Sarah and all those people back there. Carolyn, possibly an Emily. If you're not an Emily, you should be. Are you an Emily?
Yeah.
Excellent. Can you guys see that? Okay.
Yeah.
Okay. Not wonderfully, but okay. Next. Let's go, ooh. Let's throw, I won't make that really hard on you yet, so we'll go here. That's a bit of an exaggeration, that's all right. Okay, do the best you can on that. Try to reproduce that as best as you can. Close enough. Okay, what quantity is being measured with this? First of all, what instrument do you think this might be? Anyone can shout this out. Graduate zone. What quantity are we measuring? Volume. And what unit is the volume being measured in? Milliliters. See how that works out? That whole quantity thing just boggles you guys for some reason. All right, so there we go. Now, please take a moment and write down on your paper what you feel this measurement is. Don't look at anybody else's paper. Just write down like this is for your lab or a test or a quiz or something like that. What is that measurement? Be prepared to change your answer once we have a discussion. But after yesterday's, or whatever that was, Friday's little thing, you guys should be in pretty good shape. Are you a Bella? Does your last name start with a K? First name start with L? What's first name start with?
T.
Yeah, Travis. All right, moving on. Okay. Let me see. Young lady whose name might be Nayeli. What do you have? What did you write down on your paper? 33.2. Emily, what did you write down?
33.25.
See, that was different, wasn't it? Time out. Is it Reagan? Really? Wow. Anyway, go ahead.
33.2.
Okay, you had that also. Does anyone have anything different than either of these two? Anyone? Wow, that's pretty amazing that all 26 of you, I lied, 25 of you have one of those two. I'm going to go start looking at papers. I think some of you are not. 1, 2, 3. anything that's different? No, that is not that. Does anyone have any? Yes, there we go.
33.5.
33.5. Anything else? See, now the truth comes out.
33.1.
33.1. I'm assuming we're all meaning milliliters, right?
Yeah.
Okay. Hold on, I gotta work on something. Kaylee.
I have 33.25.
Okay. What do you have? I can't remember. Yeah.
Kelsey, I have 33.25.
Okay. What do you have, Bella?
33.2.
Okay. So does anyone else have anything different? So I squeezed some more out of you. As it turns out, 3. I'll bet there's at least one more out there. Who's that person? Just admit it now. Who is it? All right. Anyway. Now, wouldn't you think that theoretically, since we're all relatively intelligent people, that we should all come up with the same measurement, same instrument, right? Same quantity? Shouldn't we all come up with it? Well, that's actually somewhat false. Now, here's an interesting question. Where were if you were actually making this measurement, where, Mr. Holman took all the stuff, where should your eyes be relative to the quantity that you're measuring? At eye level. To avoid what effect? See, no one's ever introduced you to this word, I'll bet. What are we trying to avoid?
I don't have the word for it.
Okay.
But I know what it is.
There is a word, believe it or not. There is. Go ahead with the description.
It's like the water.
Oh, I see where you're going. No, that's not what I was looking for. You're going to the other thing. Okay, that's okay. You're headed in the right direction. Were you thinking the same thing she was? Okay. At eye level, well, then here, I'll help you. At eye level to what? Is this what you were thinking?
Yes, like to like the water.
To like the water. Well, as it turns out, it looks like there's numerous places that the water is. Liquid. Let's go with liquid. Okay, this little curved piece is a meniscus, correct. And where should we be making the measurement?
The
Bottom of the meniscus. Now, I over-exaggerated here a little bit. Actually, I should draw it a little bit more precisely, like this. Okay? Depending especially on how wide the cylinder actually is. Okay, on a cylinder like this, it's actually going to look fairly similar to that. Okay, narrower ones, you're going to get more of something that looks like that. Okay, but anyway, why the bottom of the meniscus?
Because the cohesive properties of water.
No, you're actually talking about why the meniscus exists. We're talking about why, I'm asking why read from the bottom of a meniscus? Why not the top? Why not here?
Because there's not a liquid all the way across there, so there's nothing.
Yeah, there's really a very small amount of liquid in this region right there. That is, did I do the hair thing in here? No, I haven't done the hair thing in here yet. Okay. Yeah, there's really a negligible quantity of liquid in that little area right there that is formed due to the cohesive properties of the water molecules to the glass molecules. Okay. So anyway, so we read from the bottom of the meniscus. But then the original question I asked was, where should your eyes be relative to that meniscus, the bottom of the meniscus? Well, someone had said eye level. And then my next question was where we ran into the problem. I think this is what you were describing, right? This whole meniscus thing?
Yeah.
Okay. My next question is, or the question I was really asking was, why do we put our eyes at eye level? We're trying to avoid the effects of a concept that you probably haven't been introduced to. If our eyes were, say, here, okay? And we were trying to read this. Well, the bottom of the meniscus appears to be matching up with what line? One that's lower, would you agree? Whereas if our eyes were here, and we were trying to read this at the bottom of the meniscus, well, actually our eyes would be higher because the higher is going to bring this over here. The scale's over here. Does that make any sense? Let me do this. See what I'm saying? It would intersect at a line that was at a higher level, whereas down here it would be intersecting at a line that's at a lower level. This concept that we're trying to avoid is called parallax. I don't know if you've ever heard that before or not. Put it this way, you guys ever, and this has actually happened quite a bit here recently, you guys ever look outside on what we would call a partly cloudy day, where you look off in the distance and it looks like it's just complete clouds, and you're thinking to yourself, oh, it's gonna be all cloudy, it's gonna be really cloudy pretty soon. But above you, or wherever you are, there's some clouds here, some blue sky, some clouds, some blue sky. And then as time goes on, it continues to be the partly cloudy thing. So that all those clouds break up, that were off into the distance, or what do you think was actually happening there?
From the angle in which you were at, it looked like there wasn't space in between the clouds.
Right, because you're seeing like the bottoms of some clouds, and then because of the angle, you're seeing the tops of the next cloud, but to you, it looked like it was just all cloud. Does that make any sense? Same kind of thing here. So we're trying to avoid the effects of parallax by looking at eye level. So we would actually be trying to read this from right there. Okay. Let me see. So what is the actual measurement? I would say the 33.1 or the 33.2 would probably be appropriate. Is 33.3 wrong? Possibly in this case. But 33.1, 33.2, we're estimating anyway, right? So, how many significant digits are there available in this particular measurement?
3.
Yeah, the 3 that were capable of being measured. Okay, next. And here's the thing, people. Whenever you're reading an instrument, I mean, we're all sitting here doing this, and everybody's getting the concept and all that kind of stuff. When it goes back in time to get into the lab and actually do this stuff, there's a large majority of you that will just do the thing that you've always done in the past and say, oh, it's about 33. You know what I'm saying? So, something that good measurements require from your side is something that a lot of you as what? Are you 15, 16-year-olds, most of you? Yeah, there's this one word that starts with a P that you're somewhat lacking right now. Patience. Patience. See, you smile because you recognize that, right? You want things done now, okay? For example, what time is it? And you desperately want to look at your phone right now, don't you? I know there's a clock right there. What time is it?
8:37.
That's cool. That's pretty good, okay? But you don't like looking at that because it takes patience to read that, right? You want the numbers right in front of you, okay? I'm not just picking on you because 90% of the other people are that same way. Good measurements require patience, okay? You'll get really good at it. You really will. All right, next. Another more common instrument that we're going to use. Kind of forgot where I was here. Now, there's more, but wait, there's more. And let's go. go. No. Okay, do the best you can. First one here. Oh. All right. Where do I want to put this? And we'll do two. We'll do two. Actually, we're going to use this one for three things. Let's go here. All right, and again, I know that the people in the back are really probably going to struggle with this one a little bit, so sorry about that. There is a spot up here by the young lady in the white and somewhat gray striped shirt, whose name I do not know. So that didn't take long, did it? The tallest person in the room decided to get closer.
Yes.
Anytime there's a space open to all right, go ahead and write down what you guys feel to be the measurement to be. Greater than that. While you guys are doing that, what instrument does anyone feel that we might be using here? A balance, very good. She said a balance. I interpret that as every single thing we've looked at is a scale. Balance is what we're using. Okay, we're using a balance. What quantity is being measured? Careful here. Mass. And what is the unit in which our mass is going to be measured? Okay, here we go. I forget. Give me a second. What's it start with? No. Wait. No, because you. Yes, Caden. No, that's somebody else. What do you got?
Chase.
Chase. That's. I knew it was one of those names that. Okay. Anyway, Chase. What do you have?
7.35.
7.35. Does anyone have anything different? Go ahead, Jason.
I had 227.688 grams.
Kayla. You don't. Well, what do you have written on your paper?
I don't understand the squares.
Oh, that's. What do you have written on your paper?
I just put 0.684.
There's a number. 6, 8, what?
4.
4. Sarah, I believe. Okay, you have one. I got nothing. What's your name? Zach, what do you got?
I have 0.685.
This is fun.
Wait.
No. What's your name start with? Yeah, because you changed it.
It's Libby.
Yeah, there you go, Olivia. There you go.
227.68.
More. What else you guys got? What do you have?
227.689.
I can't remember your name. Go ahead. Serena. time out, time out. You're the, is it a C or a K?
Okay.
Caden? Right, go ahead.
227.685.
All right. There are approximately 8 other answers floating around out there. Okay, at least that. Okay, we'll stop here because we'll fix it all right now. And then we'll go back and do like 2 more with this because there's a couple other concepts that we need to look at. Anyway, moving on. Let's eliminate, if you guys don't, well, let's do this. Since it's a balance, and I know you guys haven't used any of the 4 being balances yet, but I believe you used the 3 being balances, right? Where there were 3 things. Well, this is an extra special one. We actually have an extra bean, okay? So there's 4 beans, 1, 2, 3, 4. Each of the boxes represents 3 of those. You guys with me on that? Okay, excellent. So what do we have? We're at 200, what is it, 20? Boom, and 7. So each of those bigger sliders, the ones towards the back, represents a whole number. You guys with me on that? Okay. Here's the thing about these: there's only certain spots that they are allowed to be in, and you guys may remember this. You hear that little click? Okay. Those are the only spots those are allowed to be in. They can't be anywhere in between. Okay. Usually we don't have any problems with the big one. It's these other ones that you guys get a little weird on, and you guys try to put them in between places. You hear all those little clicks? They've got to be specifically on a particular one, okay? It's that last one that is highly variable. You hear any clicks? You don't hear anything. That thing just glides all over the place, okay? And in this case, we are in that region right there. Okay? So anyway, so there's 4 sliders there. So, with that being said, we can eliminate from our discussion this, and the 18 other ones that are out there like that. Okay? Is everyone clear on this piece now? Okay? Next, what are we going to do with this? Okay? Well, once again, remember when we're measuring, we have to write down all the digits that are known. Well, we know the 227. So these 4 actually have a chance. We know it's at least 227.6. All those are good. We know that it's at least 227.6. 1, 2, 3, 4, 5, 6, 7, 8. Doom, 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 doom. Good there. Okay? Now, it's in between the point, or the 8 and the 9. Okay? However, it's a little bit further than halfway. So this one we can eliminate. I forget who gave me this one, but if it was somebody from way in the back, I could understand where that may have come about. Okay, because you just couldn't see very well. Okay? So now it comes down to, here's the thing though. We can estimate, we know it's somewhere between the 8 and the 9. We can estimate in that region. So this one just doesn't have quite enough information. We can do better than that, okay? So now it comes down to, is it 8, is it 9? And if actually you were really close enough, a lot of you may have even put this as a possible answer. Okay? So I would actually have leaned towards more this one and this one as being really valid. The 0.6 or the 0.689, whoever, and again, I don't know who gave that one to me, but again, I'm going to guess it was somebody really towards the back, because if you came up here, you would see that there was quite a bit of space there, and that's okay. We were just doing this from where we are. So anyway, how many significant digits? How many digits were capable of being measured on this instrument? In this case, there are 5, 6. In this case, there were 6. Okay? Now, let's start playing with this. I'm not going to change any of this. Well, you know what? I am going to change this, because it's going to make our significant digit discussion more valid. to do is put the slider here. Okay, so now we have a different measurement. Okay. Now, you guys don't have to write this one down, but go ahead and write it down. Let's just see what we get. It will be kind of interesting to see what you guys get. All right. I already spoke to you. You're like a McKean of some sort. What's your first letter? Don't know. I don't know. What's your name? Andrew. Yeah, that's one of the common ones. All right. So Andrew, what do you got written down? 220.77. I'm going to guess after our discussion that many of you have that. Anyone agree? Great. How many of you have this with a 0 on the end? Good, you two win. Did our instrument change? Did we change instruments? Is it exactly the same instrument we had used before? Maya. I'll bet. Okay. It is. It's exactly the same instrument. However, when I'm reading the measurement that many of you had, this tells me that this is a different instrument than this one. Why is that? This one is capable of measuring to what decimal place? Anyone can shout it out. Thousandths place. Whereas this one only appears to be able to measure to the hundredths place. Remember that last digit is always estimated if need be, right? That means that this one would be estimated. Now, was that estimated here or was that one known? That one was known, wasn't it? That's not an estimated digit. So what a measurement does is not only gives you the amount of stuff that's there, but it also tells you the precision level that the instrument had, the how good the instrument was. Those balances are unbelievably good balances. Okay? I mean, I know there's that patience word. It requires a little patience. You will develop that at a good school to measure things here. I'll just do a little demonstration of how good these things are. Okay. If I put the hair that I just I pulled off her head and put this on there, it would measure that. It would have the ability to detect that. That's pretty good. These things are pretty good. Okay? In fact, I think most of you are noticing that. Have I touched that here recently? No. Look what's happening. You guys see that waving in the wind a little bit? Okay? These things are incredibly sensitive. Anyway, so in this case, since the slider happens to be exactly on the mark, that means it's dead on the 7. But we want to convey to whoever's reading that measurement that it had the capability of measuring to the thousandths place. We would have to put the 0. This is the first of many instances that's going to boggle you guys with the significant figure thing. How many significant digits were available in this measurement? Still 6. Whereas the measurement that most of you had, there were only 5 available. You see where I'm going with that? Okay? Here's another little thing that's going to cause some problems on occasion. Let's go here. Okay, and I don't know. Let's do this. All right, now what's our measurement? Do the best you can. way back there in the depths of the. Okay. Maya, what do you have written down?
Oh, I'm not.
Oh, you're not done yet. Okay. I forget. Pardon?
Emma.
Really?
Yeah.
You're an Emma?
Yeah.
What'd you get?
108.4603.
Anyone have something different than that? What do you have?
108.602.
Okay. Anyone have anything different than those two? What do you have?
108.604.
See, we got better, didn't we? Does anyone have anything different than those? Look how much better we've gotten already. Because that would have just completely befuddled most of you if we'd done that one first. Remember, we were coming up with point for some of that stuff. All right, so honestly, and again, it depends on where you're coming from. I'd probably agree with this one the most. Possibly this one. That's not really that close to half. So, but anyway, so there you go. Either one of those is going to be wonderful. Okay? Wonderful. All right. Once again, how many significant digits in this particular measurement? 6. Okay? So you guys are counting those zeros. Okay. Uh-oh. I just erased my 135 books. Well, as far as I can tell right now, we've gotten about as far as we need to get with measurement, as far as the skills that you guys need. Now we need to dive completely into the significant digit thing. One more thing occurred to me. You don't have to draw this one. You don't have to draw this one. It doesn't matter. It's not that big of a deal. Okay? And this color is going to be wrong, but it doesn't matter. I'm just pointing this out. There's a possibility that you guys may run into this in your lifetime. Now what does it look like I have? Is that another meniscus? Yes? What seems to be interesting about that particular meniscus? It's flipped. Now, why did the meniscus occur in the first one we were looking at? Because of we're assuming water molecules, whether it was aqueous solution or not, okay, were attracted to the glass molecules. What seems to be occurring here?
It's repelled by.
Yeah, now the liquid is repelled by the glass molecules. And you guys probably won't get very many opportunities to see this because they just all of a sudden, well, not all of a sudden, but seem to have gotten all of their panties in a bunch about this stuff. That would be like a mercury, either barometer or thermometer. Regardless, a mercury meniscus in a glass tube is going to look like this. It's going to appear to be, I forget whoever said it, flipped. Okay, because the mercury is actually repelled by the water, so it's going to accumulate in the middle. Okay. Has anyone ever seen a mercury thermometer before? Now, I see some people raising their hands. I'm going to ask 2 questions. What color was the mercury? No. Mercury is not red. Okay? What you saw was an alcohol-filled thermometer, just like the ones we have here. Okay? Same response?
It was dark.
Dark.
Yeah.
Red? No, I'm just kidding. Sarah, how about you? It was red. Okay, so we eliminate. So, Has that, yes?
Isn't mercury like silver?
Yes, it's a metal. Mercury's a metal, very silver, very shiny. Has anyone ever had the opportunity to play with mercury? It's the coolest stuff ever. Oh my gosh, we just pull it out on this kitchen table, play with it. It is so cool. Have this big cup of it, you can stick your finger in it, it's a liquid. Pull it out and it's not wet. Put it out on the table, it breaks into these little drops, you scoop them all back together, put it back. It's cool, cool stuff. Most people would recommend not doing that. A couple things, I have no hair and I'm a little crazy, so that might explain a little bit. Maybe I spend a little bit too much time with mercury, but anyway, no, I'm kind of kidding. You have to have fairly prolonged exposure to have any ill effects from that. No, it is the cool. Now everybody freaks out. Oh, mercury! It's like, oh my gosh, we used to play with that on the kitchen table. Anyway, and again, it's silver. Okay, so if you, has anyone ever seen a thermometer in which the liquid inside was silver? Right. Now here's my next question. Where was this thermometer that you saw? Hold on, don't answer the question yet because we're going to write this down on. Okay, where was it?
My grandma.
How about you? You guys are pretty amazed at this. What did I write down, Jason?
Grandma's house.
How about that? All right. Moving on. And depending on how old you are, you may see figures also. Significant digits, significant figures. Okay? Now, we've already got a head start on this because we did the whole measurement thing, and I tried to do this on purpose so you guys understand that the whole significant digit or significant figure thing is related to the values that were capable of being measured on an instrument. The word significant is not what you're used to the word meaning, okay? So, with this stuff anyway. So, significant digits indicate a number of values capable of being measured with an instrument. There is a whole set of rules that guide figuring out how many significant digits there are in a measurement. Those rules are listed on a piece of paper that I'm going to give to you right here. We're going to eliminate about 80% of those rules, okay? Because based on the information we've already looked at and what those rules try to say, you're going to read some of this stuff. I mean, it's going to be just like, here, I'll read one to you. This is always a good one. Rule number 3. Zeros to the right of a non-zero digit, but to the left of an understood decimal point are not significant. If such zeros are known to have been measured, however, they are significant and should be specified as such by inserting a decimal point to the right of the zero. Right? Here's the thing. Zeros are the only things that cause problems. I'm telling you that right now. Zeros are the only things that cause problems. I'm going to give you 2 rules. There might be 2.5 by the time it's all over with. Here's the thing. If a zero is only serving as a placeholder, and that's its only function, it is never significant. So there you go. Zeros serving only as placeholders are never significant. example, how many significant digits in that measurement? Well, there's only two. Because, first of all, there's an understood decimal point here. Would you guys agree? Okay. That means this digit was estimated. This one is capable of being measured. Therefore, if this one was estimated, do we know anything beyond that? No. These are serving as placeholders to make sure that the 7 ends up in the hundreds place, the 2 ends up in the thousands place. Everyone hunky-dory on that. That's pretty easy. Now, this one causes, I'm introducing zeros in other places.